Hello everyone, I'm Lucian, and in this session I will be covering installing Oracle Openstack on a Virtualbox environment. So we'll be talking about all of the steps necessary to do a 5-node installation, all our virtual machines running on Virtualbox. And we have, for example, 2 nodes, which I've named Con1 and Con2, running on Oracle Linux 7.2, and the roles will be control, database, and storage. We have another node called net, which is again an Oracle Linux 7 with the unique role of running Neutron services. And 2 extra nodes, comp1 and comp2. These are OVM servers 3.4.2 with the unique role of running instances, so a compute role. Regarding the amount of RAM, 24 gigs of RAM is kind of a minimum requirement. I have allocated around 6.5 for the control nodes, 2 gigs for the network, 3 gigs for the compute node. And after the deployment, I've noticed that a minimum of 8 gigs is necessary for the control node. 1 gig is sufficient for network, and at least 2 gigs for compute in order to run instances. Networking, it's all virtualized through with the help of Virtualbox. So we have the first virtual NIC called using NAT for internet connectivity. Then we have one host only. It's for the internal communication between the nodes. And a third one, which is an internal network used for private networks for instance traffic. Additionally, the net virtual machine has a fourth virtual NIC. All others have just these 3, and it has access to and delivers external communication to the instances through the help of floating IP addresses. And in my case, I'm sharing that from a host only to network, so it's separate from it's a different network than the first host only. But you could, for example, add a bridge, and then you will have the instances could have connectivity outside of your VirtualBox environment. Regarding prerequisites, I will disable SA Linux and firewall. I will make sure that the time is synchronized. BTRFS file system is necessary for running Docker containers. In order to run Cinder, you have to have a specific volume group, which is named Cinder-volumes. Now, regarding repositories, you have to have enabled Oracle Linux 7 repositories for the control nodes and for the network nodes. And for the OVM server, we will be using Oracle Linux 6 repositories. And make sure the latest for both OL 6 and 7 add-ons are enabled: OpenStack 3.0, OpenStack Extras, and UEKR4. They have to be enabled. For OVM server, specifically, you have to disable OVS agent and iSCSI daemon. Regarding packages, for Con1, which also will play the role of my local Docker registry, I will install a bit more packages besides Docker Engine and Cola pre-install, which I will be installing on all of the 4 nodes. Especially for Con1, I will be installing the Cola CLI, some tools to drhive, and some networking tools and some Cola utilities necessary for my environment. Something different is in versions 3 compared to version 2 is a virtual IP address in an Ansible configuration file. By default, it points to the IP address of 10.10.10.254, and I will change that accordingly to my network configuration. So in my case, it's gonna be 192.168.56.110. This environment uses also HA proxy and load balances between the 2 control nodes, and the virtual IP address in my case will be this specific one. Now, the best choice from Oracle's point of view is to use Oracle Container Registry or the Docker Hub. But if you'd like, and I'll be also showing the more complex demo, is to create a local Docker registry. And for that, I will be showing you the Docker configuration necessary, how to generate the self-signed certificate. All the VMs will have the same Docker configuration, same certificate. Then I will be creating the Docker registry container necessary for hosting the Docker images, which will come in a zip format, and you can download them from the edelivery.oracle.com. Search for Openstack, then copy the zip file on the control node on the local Docker registry and import those images to your local Docker registry with the import command to registry script, and then run CLI commands. For example, for setting up OpenStack release admin password, you could generate remaining passwords, add virtual machines as control nodes in this OpenStack environment, set up the root passwords for them, set up the roles like control database storage will be handled by con1 and con2 virtual machines, network role for net, compute for comp1 and comp2. Then I'll be setting up the Docker registry, pointing out to my local Docker registry, set up the internal IP address pointing out to the same as from the Ansible configuration file. This will be my virtual IP. Network interface will point to the host-only network. The tunnel interface will point to the internal network, and external interface available for the last fourth virtual NIC. In my case, points to the host-only to network. And then we'll call a CLI deploy, and we'll be setting up the environment. Let me show you also the Virtualbox that I have. So I have these 5 virtual machines which will be having the roles. And talking about resources, 6.5 gigs for control nodes. I have 2 virtual disks, and the network is not host only and internal. A compute example. The first disk is OVM server install, default install, and the second one, 60 gigs, is used as a BTRFS file system for the Docker containers, not host only internal. And the network, the only difference is it has an extra fourth NIC, which which in my case points to host only to virtual network. Okay, let's proceed now with what steps I have already made, and let's check, for example, the fact that I have disabled SE Linux. And I'm gonna test on con1, net, and comp1. All others have the same configuration. And the same on comp1, which is the OVM server. Now, what I have already done is that I have disabled firewall D. As you can see, it is disabled. I have also installed NTPD. Now you can see that. Let's check the status. At the moment it's not running, so let's begin with that. I'll be starting NTPD. I will enable it to boot up by default at startup. I will disable cron ID. Same steps will apply to all Oracle Linux 7 nodes. So here will be the console node, Con1 and Con2 and net. They have the same basic configuration. Now let's check, for example, the IP configuration. So as you can see, I have ENP0S3, which has a NAT IP address, so it's for internet connectivity. ENP0S8, it's the one connected to the host only. And this is the IP address that I have logged in right now. And ENP0S9, it's an internal access only, 172.16.0 subnet. Now, another thing that I could show you is, for example, the fact that I have a specific volume group, which is named Cinder minus volumes, used by the Cinder service. And in my case, it's a small 12 gig, the second disk that you have seen in the Virtualbox configuration. Some other aspects that I want to show you is, of course, the repository configuration. So you will see latest is active. You will see UEKR4 is active. Add-ons is active. And of course, Openstack 3.0 and Openstack underline extras. These are the only ones that are active right now. And it's the same configuration on Oracle Linux 7 nodes. Now we can take a look on the compute node. So net and con1 has the same exact configuration. Let's check an OVM server. For example, let's check the IP tables, the fact that it's already disabled. You have seen the get enforce command. We want to make sure that the OVS agent is disabled. So we are doing this right now. We are stopping the OVS service. We are stopping the iSCSID, which may have strange behavior on OpenStack, so we need to make sure that it's disabled. And we have done that right now. The IP configuration is the same. So same thing now. BTRFS, it's another thing. For example, here we could check the file system on root and we'll see /var here. It's around 54 gigs, and with mount you can also see that /var is a BTRFS volume. Same thing here. It's in /var varlib docker for the OVM servers, and is again BTRFS. Varlib docker in this case. Okay, that's one step that I have previously done. And also let's check the IP table, the repository. As I said, it's based on OL6, so OVM servers will be using the repository from OL6. Latest is enabled, add-ons, and UKR4. You can see it's enabled, and also OpenStack 3.0. You can see here it is enabled as well. Okay, with that in mind, you've seen some of the prerequisites that are necessary. Let's proceed now with the installation. So Con1 will have multiple files because it's the main node and will host Docker registry, so we need CLI and Docker Openstack utilities, also some drhive tools. So I'll be installing this on the on Con1, and all the other nodes will be only having the Cola pre-install and the Docker engine. For example, for comp, I will accept, continue the installation, and same thing to do with net. And again, con2 and comp2, these are just an example so you can see the process basically. The OVM servers will move a bit more slower when installing. OL7 will be a bit faster in this case. So I will accept and continue with the installation on the remaining nodes. Let's go back to comp1. I will make a short break and we'll continue when the packages have stopped installing. And now you can see the packages have been installed on Con1, Comp1, and also on Net. And now we'll continue with the configuration steps. After installing the packages, now we'll be starting to configure. As I was saying, OpenStack 3.0 comes with a specific Ansible configuration file that you can find it here in USR, share cola, Ansible, group vars, and then global. It comes with a default virtual IP address of 10.10.10.254, and in my case this doesn't matches my environment, so I will exchange that to 192.168.56.110. This will be the same as my Horizon dashboard, and this virtual IP will be also used by the HA proxy and balance between Con1 and Con2 control nodes. That being said, I will be proceeding with the Docker configuration. We will be specifying the local Docker registry, and also that SA Linux is disabled, and also that we're using BTRFS as the file system. I will be inserting root user into Cola group and create a specific place to keep the certificates that I will be generating now. Now I'll be generating the private and public key. Common name has to match the full FQDN of my hostname. I will limit now the writes on the private key so that only root can access it, and we'll create a dedicated directory to keep the public key for the Docker registry, and the same I will be doing for the other nodes. I'll be rebooting Docker. Docker is now restarted. And also in the meanwhile, I will string the zip file containing the Docker images. While this will be over, I'll be proceeding with some other steps. Like for example, creating the Docker registry container, which will host these images. So I'll run this large command and specifying that this Docker registry will be running on the port 5443 instead of the default 5000. And the reason for that is that Openstack Keystone will be using the same port number. While this will finish, in parallel we can start doing same Docker configuration. And for example, we can begin with net. We'll go in Docker and add the necessary configuration parameters. We'll be creating the same directory. And we'll copy the certificate, the public key, to all other nodes in the environment. And also good idea would be to copy the etc hosts on the same node so that we have the same configuration on all of them. Let's start with the net node. And as I said, the etc hosts. And let's see what the file has. So here I'm specifying the con-vip. This will be the virtual IP address that I have used in the Ansible configuration file. Also will be the same for the Docker, for the Horizon dashboard. Con1, all the nodes, the IP and the host name, also the tunnel interfaces on the internal network, and the last one are the floating IP addresses that we will be using for access, external access from the instance to outside of the OpenStack environment. I have managed to copy the zip file in the meanwhile, and now we'll be moving the file to the varlib registry. Now the zip file has been moved. We will start the archiving it. And I'll be continuing with the import. I'll make a big screen. Specifying my host name and the port 5443. This will take around 45 minutes in my demo environment. I'll make a break now and continue when it stops. And as you can see, the import has now finished, and we will be proceeding with the latest steps, which will involve some call CLI commands. So now I'll continue with the call CLI commands, and we'll be specifying the Docker, the OpenStack release. Then we'll set up the admin password that will be used for logging in on the Horizon dashboard and also in the CLI mode. We will generate the other passwords, or you could manually set up if you'd like that. Then we will be just adding the nodes. And with the setup, we will be also specifying the root passwords. Same for net. They have already been introduced, but if it's not the case, you will have to specify the root password. And finally for comp2, then we will be specifying control rights. I have already specified this before. So with the host list, you can see that comp1 and comp2 are the compute nodes, con1 and con2 are control storage and database, and the network role is for the dedicated net VM. That being said, we still have to specify Docker registry, which is hosted on con1.local and port 5443. External, first of all, call our internal address. This will match the virtual IP address 56.110, which will be balanced by HA proxy between con1 and con2. network interface. This will be my second virtual NIC, which is a host-only one, used for the traffic between the nodes. Tunnel is the third one, used for the private networks that the instance will have. And external, dedicated for the instances that will require external access outside of Openstack, in this case ENP0S10. And all steps have been correctly introduced, and we will start the deployment. This will take around 25 minutes. I will make a break now and we'll continue from there. Now you can see the deployment has finished successfully. Thank you very much for your attention. This concludes the session.